Section 1.1, Functions. In this section, we're going to make sure that you're familiar with functions and function notation. Both will appear in almost every section in a calculus class, so you will need to be able to deal with them. First, what exactly is a function? The simplest definition is an equation will be a function if, for any x in the domain of the equation, the domain is all the x's that can be plugged into the equation. The equation will yield exactly one value of y when we evaluate the equation at a specific x. This is usually easy to understand with an example. So for example 1, it says determine if each of the following are functions. The first one is y is equal to x squared plus 1. This first one is a function. Given an x, there is only one way to square it and then add 1 to the result. So no matter what value of x you put into the equation, there is only one possible value of y when we evaluate the equation at the value of x. Part B, y squared equals x plus 1. The only difference between this equation and the first is that we move the exponent off the x onto the y. This small change is all that is required in this case to change the equation from a function to something that is not a function. Now, to see that it is in the function is fairly simple. Choose a value of x, let's say x equals 3, and plug it into this equation. So if we plug 3 into this equation, y squared equals 3 plus 1, which is equal to 4. So y squared is equal to 4, and that tells us that there are two possible values of y that we could use here. We could use y is equal to 2 or y is equal to negative 2. Since there are two possible values of y that we get from a single x, this equation isn't a function. Note that this only needs to be the case for a single value of x to make an equation not be a function. For instance, we could have used x is equal to negative 1, and in this case, we would get a single y is equal to 0. However, because of what happens at x equals 3, this equation will not be a function.